In this video, we carry on with the power rule for integration, and this time we're going to see how to integrate things like the square root of x or the cubic root of x. As a quick reminder, the power rule for integration states that the integral of a times x to the power of n is equal to a over n plus 1 times x to the power of n plus 1 plus some constant of integration, c. Now at this stage we know how to integrate things like x squared or 3x to the power of 4. We've also seen how to integrate things like 3 over x to the power of 5. But what if we had to integrate 2 times the cubic root of x? Well, luckily for us, any root can be written as a power of x. Indeed, the nth root of x to the power of m is equal to x to the power of m over n. For example, the cubic root of x squared is equal to x to the power of 2 over 3. Or more simply, the square root of x is equal to x to the power of 1 over 2. Let's say we have the fourth root of x to the power of 5. Then that would equal to x to the power of 5 over 4. Now, keeping that in mind, let's go ahead and see how we would integrate 2 times the cubic root of x. Well, using what we've just said, the first thing we're going to do is rewrite this by replacing the cubic root of x by a power of x. So that would look like this. The integral of 2 times the cubic root of x dx equals to the integral of 2 times x to the power of 1/3. We now use the power rule for integration, and we can write that this equals to 2 over 1/3 plus 1 times x to the power of 1/3 plus 1, plus some constant of integration. We now take care of the denominator. 1/3 plus 1, that's equal to 4/3. So this is equal to 2 over 4/3 times x to the power of 1/3 plus 1, which is 4/3, plus c. Now, 2 divided by 4/3 is the same thing as 2 times 3/4. In other words, we multiply by the reciprocal of the denominator. That's 2 times 3 over 4 times x to the power of 4/3 plus c. Now 2 times 3/4, that's equal to 6 over 4 times x to the power of 4/3 plus c, and carrying on over here, 6 over 4 is equal to 3 over 2 times x to the power of 4/3 plus c. Finally, we can write the x to the power of 4/3 as a cubic root again, and we can write this as 3 over 2 times the cubic root of x to the power of 4 plus c. So that's how we can use fractional exponents to integrate things like square root of x or cubic root of x. Now, let's work through a few more handwritten examples. As a first example, let's integrate the square root of x. So the first thing we'll do is write this square root of x as a power of x. And following up on what we've just seen, that would be the following. That's the integral of x to the power of 1 over 2. Now that we've done that, we can use the power rule for integration to write that this equals to 1 over 1/2 plus 1 times x to the power of 1/2 plus 1 plus some constant of integration, c. Now, on the denominator, 1/2 plus 1, well, that's 3/2. So we have 1 over 3/2 times x to the power of 1/2 plus 1, which is 3/2, plus c. Now, 1 over 3 over 2, or 1 over 3/2, is the same thing as the reciprocal of the denominator, so, meaning to say that's the same thing as 2 over 3. And this multiplies x to the power of 3 over 2 plus the constant of integration. We could stop there, that would be perfectly acceptable as a final answer, but we could also write the power of x back in, I want to say, root form. So that would look like this. That would be 2 over 3 times the square root of x to the power of 3, plus, of course, the constant of integration. And there we have it. That's how we integrate the square root of x. On to the next example. We have to integrate 4 times the cubic root of x squared. So once more what we'll do is we'll start by writing the x term as a power of x. And that would be the following. We'd have 4 times the cubic root of x squared. That equals to the integral of 4 times x to the power of 2 over 3, 2/3. Now we can use the power rule for integration to integrate this. That leads us to 4 over 2/3 plus 1 times x to the power of 2/3 plus 1, plus our constant of integration. Now on the denominator, 2/3 plus 1, well 2/3 plus 1 is 5/3, so we have 4 over 5/3 times x to the power of 2/3 plus 1, 5/3. And of course, plus c. Now 4 over 5/3, that's equal to 4 times the reciprocal of the denominator, so that's 4 times 3/5 times x to the power of 5/3 plus c, and 4 times 3/5, that's equal to 12/5 times x to the power of 5/3 plus c. Once more, we could stop there, but we could also write this back as a cubic root, and that would look like follows. That would be 12 over 5 times the cubic root of x to the power of 5 plus c. Okay, let's look at a couple more examples. Let's integrate 4 times the 6th root of x to the power of 5. Well, once again, our first step is to write this x here as a power of x. That would be, 4 times the 6th root of x to the power of 5 dx. That's equal to the integral of 4 times x to the power of 5 over 6 dx. Now, using the power rule, we can go ahead and say that this equals to 4 over 5 over 6 plus 1 times x to the power of 5 over 6 plus 1 plus a constant of integration c. Now we take care of the denominator. This is equal to 4 over 5 over 6 plus 1. Well, that's 11 over 6. So that's 4 over 11 over 6 times x to the power of 5 over 6 plus 1. Again, that's 11 over 6 plus c. Now we take care of the denominator again, or this fraction I should say. 4 over 11 over 6, that's the same thing as 4 times 6 over 11. So that's 4 times 6 over 11 times x to the power of 11 over 6 plus c. Now 4 times 6 over 11, that's equal to 24 over 11 times x to the power of 11 over 6 plus c. We could stop now, but we could also write this back in root form, and we can write that this equals to 24 over 11 times the 6th root of x to the power of 11 plus c. One last example, we're going to find the integral of 3 over the square root of x. Well, one more time, the first thing we do here is we write the term with the x as a power of x. And in this case, we can actually see there are two things going on. We have a square root of x, so we're going to have to use a fractional power of x. But on top of that, this square root of x is on the denominator, so it's going to be a negative power. So that would look like follows. We'd have the integral of 3 over the square root of x. That's equal to the integral of 3 times x to the power of negative 1/2. We now use the power rule to write that this equals to 3 over negative 1/2 plus 1 times x to the power of negative 1/2 plus 1 plus some constant c. Taking care of the denominator, that's 3 over negative 1/2 plus 1, that's 1/2, times x to the power of negative 1/2 plus 1, that's 1/2 again, plus c. Now 3 over 1/2, that's equal to 3 times 2 times x to the power of 1/2 plus c. 3 times 2 is 6, so this is equal to 6 times x to the power of 1/2 plus c. We could stop there, but we could also write this x to the power of 1/2 as a square root of x. And that would be 6 square root of x plus c. And there we have it. That's how we can deal with fractional exponents and roots of x and the power rule for integration. I hope that helps.